Yeah, this is a collaborative work with Yusheng Qi and Siming Chen from Fudan University, and Qingchen Yangshi and Nan Cao from Tongji University. And I'm now with University of California, Santa Barbara. So visualization system has been recently introduced in public culture centers, museums, and websites, accessible via touchscreens, computers, and mobile phones for public education tasks. In the past 10 years, researchers have made considerable efforts to create large and advanced visualization systems for audience to browse and explore, such as M-Dialog, DeepTree, and Living Liquids as shown here, which are the more important foundations of museum visualizations. However, visualization systems constructed of multiple linked view and interaction types are often complicated. Which interaction to operate and which part of data to explore are hard questions for public users. Making these decisions largely relies on professional experience and analytic abilities, which is a huge challenge for non-professionals. Through our interviews and literature studies, we concluded that users feel hard to construct interactions in visualization systems without proper guidance and instructions. So facilitating users' exploration in the visualization systems has become a significant priority. While most of the current research is limited to single-view visualization systems or consider users' one-step interaction, which is unable to support visualization systems with multiple views and interaction types. So in this work, we provided a solution that targeting the above challenge. We're primarily focusing on designing a model to generate interaction recommendations for public users. To be more specific, the following discussion is set within the museum scenario, but we also argue that the pipeline can be generalized into different visualizations under these scenarios. So public users here are defined as regular museum visitors with different background, has little knowledge about the topic and data analysis, but are curious to explore more for the insights. The provided interaction recommendations should satisfy the following requirements. Real time, when users face the visualization system, we believe the most straightforward way is to provide recommendations right after one interaction is made. Diverse, the recommendations should support a cross-view and various types of interaction. This can help users conduct more in-depth explorations and help the system be fully utilized. Insightful, the system should offer insightful interaction recommendations that lead to valuable explorations and deepen the user's understanding about the topic she explores. The model performs as an end-to-end pipeline with users' previous interaction logs and visual states as the input and the recommendations of the next step as the output. In the user's workflow, each time a user makes one interaction, the system will collect the interaction and visual states and then transform them into numerical vectors. In the predicting workflow, the pre-trained models receive the data and output the predicted vectors. After being converted into the JSON data structure, the recommended interactions will be sent back. So we developed a taxonomy of interaction logs based on the previous methods. Then the encoded interaction logs will be divided into 4 parts that can define one unique interaction form from the interaction types we considered. The user's interaction is recorded and converted to the JSON format. We then apply an embedding method using the context-free grammar representation. Then the multidimensional vectors. So for instance, here in this example, the user performed a brushing on the map view. So we collect the brushing and the map view and also the corresponding coordinates of where the brushing bounding box is, and then convert it to the tree format, then to the numerical vectors. We also compared several sequence analysis models and found that the LSTM model shows significant advantages under this task because it considers users' historical interaction data and mimicking users' cognition ability, and is easier to set up. So the model captured key embeddings of previous interaction logs and visual states and output the interaction embeddings of the next step exploration. Instead of using a static model, we divided the model parts into two parts. The training part cleaned the collected data using two filters of diversity and insightfulness to ensure the data quality. We compute the entropy of users' interaction to measure the degree of diversity and keep the interaction log only if the entropy is higher than a threshold. And an interaction is insightful if it involves interaction within the insightful data area we define. And the continuous learning part we achieve by when a user rejects one interaction, we collect the actual interaction and use the collected data to continuously fine-tune the model to improve the performance. This example shows one time of interaction recommendations. So the model captured these interaction logs and returned the different recommendations as highlighted in this chart. We can see there's highlighted bars here, and it reflects the concept of mixed initiative in our method. And we also propose an interactive visualization system in the museum scenario as an example to implement and test the pipeline. The 4 different points from Song Dynasty are selected. The data consists of temporal trajectory data of when and where a literature was created and its content. 7 different interaction logs types are encoded based on the different views in the system as listed here, and we also obtain the corresponding visual states and transform them into low-dimensional data. And the training data was collected from 47 participants. More than 4,000 interaction log vectors are collected. The training duration, the accuracy, the loss value, the mean square errors are compared, and 3 models within the best prediction performance are selected. Also, we create an ambient experiment to evaluate the performance of the weighted filters and also the model updating. We can see from the table that the filters improve the degree of diversity and degree of insightfulness, and also the model updating increased the model's predicting accuracy. This video clip will show how the system works. There's no audios here. No, I don't think so. Can you hear from here?
Based on the background information, we know that Su Shi was born in Sichuan province and spent the last years in his life in the southern part of China. Therefore, we start our exploration in Sichuan province. We first zoom in and click on the marks on the map view for browsing. After a while, the system starts to provide recommendations for us. We follow its suggestions and gradually be away from his hometown and approach to Kaifeng, the capital of the dynasty at that time. The system inspired us to brush the area around Kaifeng for a deeper investigation. With its suggestions, we clicked Huaiyin, Weishi, and Kaifeng on the force-directed view and discovered their locations on the map. The system later suggested us to explore the histogram to see his journey in a certain period of time and his creation. After that, the system led us to explore the south step by step, based on the given recommendation.
We further conducted a control user study and in-depth interviews for evaluation. Please find more details in our paper. So this work involves trade-off relationships in many aspects and need to be further considered. First, the balancing between diversity and insightfulness determines the weight of 2 filters. Second, whether we should keep the presented information clean and concise or provide more exploration of why these interactions are made should also worth discussion. Thirdly, there are differences between providing recommendations to public users or professionals. And also, we would like to compact our method into a toolkit that can be added into the existing visualization system to improve the generability. So what we can take away from all of this, including for following 3 aspects. First, we propose a method that models interaction logs from different views and interaction types into vectors that share the same structure. Second, we propose a mixed initiative approach for across view and interaction types recommendations and can provide real-time, diverse, and insightful recommendations. Thirdly, our approach is proven to effectively help public users gain more knowledge in the public education scenarios, thereby improving the accessibility. For more information about technical details, case studies, and evaluation, please take a look at our paper. Thank you, and welcome all the questions. Thank you.